Okay. Hi class, this is going to be the last video tutorial, okay, hopefully. So anyway, so we're going to talk about assignment number 8, and some student had trouble with problem 5, 6, 7. So I'll just focus on these 3 questions here. So this is problem number 5, and it reads this: instructor wishes to see whether the variation scores of 23 students in her class are less than variance of the population. The variance of the class is 198. Is there enough evidence to support a claim that the variation of students is less than the population variance, sigma x squared equal to 225 at this level? Okay, so when you read the question here, number 1 here, of course, this is hypothesis testing, and the second of all, you had to see number 1 step is what are you testing here, right? Apparently, what you're testing is the variance, okay, the population variance here. So step number 1 always is state, okay, state this null hypothesis and identify the claim. Okay, so H naught, okay, is always an equal sign. So what is it equal to? Equal to a constant, which is 225 here. And H1, right? This one you have to read from the question here. What's the alternative hypothesis? So here is the question here. Is there enough evidence to support the claim that the variance of the students is less than the population? So basically, you're talking about is so you're basically talking about the sigma square is less than 225 or not, right? So that's your alternative hypothesis. Traditional methods is very simple. Traditional methods basically step number 2 is to calculate this critical value. Huh? Yeah. So critical value based on the alpha, which is 0.05. So what you need to do is you need to, okay, when you look at this one here, that's basically means that this is a left tail test. Okay, because of the less sign here, and you're trying to find the critical value for a chi squares distribution here, basically, right? Okay. So here's a chi square distribution. What it look like here, and then this is chi value here. Okay, so you're looking for left tailed, and basically alpha equal to 0.5, and then you have to figure out what's the degree of freedom, which is which 23 minus 1 is 22, right? That's your degree of freedom here. Okay, and you're looking for a critical value chi alpha square, right, at this value, which is basically looking for 0.05 square here. Okay, so let's look at our table. Let's look at our table here. This is chi square. So you look at this one here. What it tells you here is it tells you the area. When you see chi alpha square, it tells you the area to the left, okay, which is alpha here. Okay, which is alpha here. We're talking about left tail test. So basically, you're looking for an area, right? Not to the right, to the left, which is 0.05, right? 0.05 here. All right. So then, how should I make use of this? How should I make use of the table then, right? Let's the table here. Let's go back here. Okay. So, so you're looking for a certain value here, and this portion is 0.05, right? You're looking for this. Okay. So what would be this value at here? Now, if this is 0.05 here, guess what? You are gonna have, right, over this region, how much? 0.95, right? So basically, you actually, from the table, you actually should look for this value here, and you should look for this. So let's see, what is that? Chi 95%, okay, value, okay, with this much of degree of freedom. So let's see here, right? Yeah. So 0.05 with 22. 22 is here, okay, and we're looking for alpha equal to 95 here, the third column. You go down here to 23. Where is it? So 22, yeah, right here. So it's actually 12.338. There, right? So this is a value over here. So this is basically here 12.338. Okay, 338. Okay. Okay, so this is your critical value here, right? This is your critical value. What critical value means, because it's a left tilt test, if you have a test value falls to the left of this critical value, then you reject this H0. Otherwise, you are not going to reject H0. So then the next thing is test value. Okay, so T and the T test value. So you're talking about the chi value. So chi naught square, right, equal to a minus 1 s square over sigma naught square. Okay, so s is given 198, and sigma naught square is 225. You get 19.36. Where's 19.36? 19.36, of course, must be on the right, somewhere here. Okay, so that must be that means the decision is not to reject H0. Okay, as a matter of fact, this is your claim, right? Because I read the question, that's your claim, right? That's a claim. So in the end, you can summarize, right? Okay. Summarize, there is not enough evidence to support a claim. So that's traditional methods here. Okay, so let's try the p-value approach. The p-value. So the p-value is actually the other one. Basically, let me redraw. We don't have to read. So basically, the first step is the same thing, and then you also need to calculate test value. All right. Yeah, so let's take a look at the chi here. There we go. So anyway, our test value calculates 19.36. So let's see, 19.36 here. So the p-value, basically, this is a left tilt test. And then the p-value is essentially referred to how much area to the left side of this 19.36. So this is going to be the p-value. Okay. Basically, you make this 19.36 as a critical value, and then you calculate this area to the left of here because it's left tilt. Then you gotta ask the question. Basically, this means if you reject, right? If there's another value, okay, if there's another value here or somewhere else, okay, but if you reject H0, okay, the risk that you are making a mistake, okay, for rejecting H0 while H0 is true. Is how much is this, okay, which is represented by the area underneath the curve at here. So we need to find the p-value, okay, well, the area underneath the curve corresponding to this guy here. Okay, still we try to make the table here. Okay, yeah. So the table here basically say we go to 22 and then try to find 19.36. Well, look at that. There's no 19.36 here, right? There's no, right? All you have here is 14 something, and then you jump to 30. So I guess the range is too much here. But for sure, what you need to know is, look, my 19.36 must be greater than this guy here, right? Must be greater than this. Then how much area, right? You look at this one here. How much area is 14.04 here? 0.9. Look at that, 0.9 here. So 14.04 is 0.9 and here. Okay, so what does that mean, right? That means there is an area of 0.9 to the to the right of 14.04, right? Okay, so anyway, so let's see right now here. So what I can find is, so we find, okay, 19.36, okay, which is beyond this 14 point, how much? 14.04. Okay, and the 14.04, basically the chi 14.04 gave me like 90% here at v equal to 22. okay, at 22. So if I draw it here, where's it? 14.04? 14.04 must be somewhere here, right? Because it's less than that. So this is 14.04, okay? And that area to the left is 10%, sorry, 90%, okay? Well, now you gotta be careful here. What are you looking for, right? You're looking for the area for this guy to the right, right? To the right. Okay, now let's see if the logic makes sense now, okay? Since 19.36 is greater than 14.04, so this means what? This means, okay, this means the area, okay, to the left of 19.36, okay, must be greater than 10%. Okay, must be greater than 10%. Right? Does it make sense? Yes, of course. You see, because 1404 means 90% to the right. And that means 19.36 must have a less than 90%, right, to the right, which means you must have a greater than 10% to the left. Okay, yeah, so that means this. Okay, that's our p-value, basically, right? This is our p-value. It's not accurate, but it's enough to make a decision, because, right, with alpha value is 0.05. That's your threshold. If this is less than greater than 10%, it must be greater than 5%. So, which means you're not going to reject this H naught right here. Okay, so the same conclusion as before. Okay, so that's the first question. Number 6 and 7 are tests on the difference of means. Okay, so so you got to be careful here, basically, what are you looking at here? Okay, because when you test the mean, you have a z-test, you have a t-test. When you use z-test, that means you know the variance. Okay, when you use a t-test, that means you don't know the variance. And in this particular case here, I don't think the problem number 6 tells you what the variance is for the two populations. Okay, so you don't know the population's variance. Okay, so in this case here, you're gonna need this t-test. Okay. And it also specifically said here the populations of the normal with equal variance. So variance unknown, but they are equal. Then you use the t-test. Okay. I'm not gonna go over everything, so let me probably just let's see, just go over maybe the p-value approach here. Okay, just p-value. Okay. So list all the available informations here. Okay, so list the available information. X bar equal to 85, x1 bar, so that's the sample mean. X2 bar equal to 81, S1 equal to 4, S2 equal to 5, N1 equal to 12, N2 equal to 10. Okay. In order to calculate our test value T naught, right? If you remember that T naught, okay, is equal to x1 bar minus x2 bar minus t naught, okay, over sp square root 1 over n1 plus 1 over n2. So anyway, that's a t and test value. So you need a so-called the pooled estimate, pooled estimate of variance sp1. Okay. So the other thing is, I guess I need to put down the hypothesis first. Okay. That's our step number 1, and always step number 1. So when you put it on step hypothesis here, the tricky here, read this right here. Can we conclude that at this level of significance that the abrasive wear of material 1 exceeds that material 2 by more than 2 units? So what does that mean is, yeah, you're looking at the mean difference for null hypothesis, which is 2, and the alternative, which is greater than 2. Okay, yeah, so that's the then you calculate step number 2, calculate this test value. Okay, test the test value. So you need to calculate SP here, right? SP equal to root, okay, and n1 minus 1 s1 square, n2 minus 1 s2 square over n1 n2 minus 2. Okay, that's SP. So anyway, you calculate this. So should be this value. Okay. Oh, well, that out of range here. So that should be 4.478. Okay, yeah. Okay, so then calculate the test value. T naught, it should be about 1.04. Alright, test value here. So now let's try to look for the p-value. Draw the distribution, t-distribution here. I put down the t naught somewhere, I don't know, 1.04, or right here, 1.04, let's draw it here, okay? So you would look at the test. So you're looking for is a right tail test. Okay, so basically the p-value we're looking at is the area to the right of this test value. That's your p-value. Okay, so how do I find the p-value? Use the table. Let's see, go to the table here, table here. T table. Degree freedom. Okay. Now the degree freedom here, right, is how much degree freedom here? Right, degree freedom, you have to be careful here. Okay, the degree freedom here. Let's go. Let's move it down a little bit here. Okay, let's move it on this one here. Yep. And because you have 12 sample there, and N1 plus 12, E2 equal to 10, so your degree freedom is what? 12 plus 10 minus 2, 20. Okay, so go to that T table here, go to 20. Okay, look for the value 1.04. Look, I don't have anything that's 1.04. Right? But the 0.04 is it must be on the on this side here, right? It must be on this side here, 1.32, right? So 1.325 corresponding to the area of 10% to the right. Okay, so what I find is this. What we find is 1.325 has 10% to the right. Okay, and because your T naught is less than 1.325, so that means the p value must be greater than 10%. Okay, yeah. So as a matter of fact, if you use Excel, you can find the actual p value is about 15.5%. Okay, yeah. So the actual one equal to 15.5%. Okay, and this is quite high value, right? If you want to make a decision, this one has a level of significance 0.5, so that is definitely not going to happen so you're not going to reject this H naught here, right? So not reject H naught. Okay, yeah, so that's number what's that? Number 6 question. Okay, last question. Okay, this one here. Well, I guess this one here you were given the population standard deviation here. You have also the standard deviation of the second population, and you have a hypothesis of this. So what you're looking at essentially is a z-test, right? Okay, and the other thing is the hypothesis is this guy here. Okay, the hypothesis is this. But in our case, we generally think as mu minus mu2 equal to d naught or not. So in this case, basically the d naught equals to 0. Okay, yeah. So then the rest of the work is fairly straightforward. Okay, so this is your h naught, this is your h1. So you're looking at is a two-tailed test. Two-tailed test. So calculate test value. Okay, test value. So test value z naught, okay, equal to x1 bar minus x2 bar minus 0, okay, root. Okay, so you're gonna have these equations later. Okay, calculate this. That should be this. Then look at Okay, look at that distribution, 4.22, somewhere here. Okay, yeah. Okay, so then let's maybe use our Z table. Okay, Z to go to 4.22. Go. Where's 4.22? Well, I guess I don't have a 4.22 here, right? You know what? But look at this one here. So this table here tells you is how much area to a Z value on the to the left, right? To the left. Well, because it's symmetric case here, so if you're looking for a 4.2 area to 4.22 to the right, then basically that would be you looking for same as saying you're looking for a negative 4.22, right, to the left. So where's the negative 4.22? Oh, there we go. There's a negative 4.0. There's no negative 4.22. But look at the value, right? The area to the left. The area to the left of this 4.0, it's almost 0 actually. It's 0.0003167. Okay, so if it's negative 4.22, then the area to the left of this guy must be even smaller than this one now, right? It must be even smaller than it. So, but what you can really conclude is, you can conclude is when it's for the value of 4, that corresponding to an area, right, of how much is that again? That's the area 0.0003167. 3 zeros, 4 zeros. There we go. That's so small. And and you're looking at 4.22. Okay, so that means the area, okay, to the right of that, right, must be less than, slightly less of this one here, right? Slight less than this. Now you're looking at is a two-tailed test. Basically, you need to what? Multiply by this value here. Multiply this value by 2. So that's your p value. So then the p value equal to twice as much of less than twice as much of this. Right? Twice of this. And still very small. It's still very small. So for such a small p-value, which is definitely less than 0.05 or whatever the level of significance you're given, right? And there is literally no risk, for rejecting your H naught. All right. So anyway, make sure you understand how to use the table properly. Okay, understand the concept, understand how to translate the language into statistical expressions, right? So that's the key part of this hypothesis testing. Let me know if you have any questions. Okay, be happy to answer you. Thank you.